Okay, so you've got a blank Excel spreadsheet that's open, and we're just going to set up where you're going to put your data. So we've got some raw data. I've just copied and pasted the pendulum independent variable from the class data that we've used, but this is where you put your 5 values for your independent data. Now just up the top there, I'm just clicking on that button to make sure that I've got enough significant figures that I used when I was measuring the length of the string. Alright, and so because we measured the time period for the oscillation for this pendulum experiment, we did each length 5 different times, and then we're obviously going to calculate an average. Alright, so just setting up some headings to make it easier and to spread our human error of our reaction time over this. We did 5 oscillations, alright, for each of those times rather than just one. Okay, so we actually are only going to be interested in the time for one oscillation. So what I'm doing here is just prepping a title for when we get to that. So I've just copied and pasted the data that you guys got from the experiment, but you guys would obviously input your own data in here. Then we're going to just calculate an average for each of those bits of data. So you just type in equals and then type in average and then select your data. Now at the bottom there's a little square at the bottom of the cell. If you want to repeat the same thing, what we've done here is we've now worked out the time for one oscillation, so just your average time divide by 5, and again just click and drag down the bottom. Okay, so we've got our basic stuff. We now need a graph because we need to work out what kind of curve we have, and it's very hard to see that from just our data. So we're going to select our independent and our dependent variables, and we're going to go up to insert, and then we're going to click on the box that says XY scatter and just click on that first scatter plot. Alright, so this is that graph that you have. Now this one doesn't look particularly non-linear, but you should get a non-linear graph. Now if your data, or if your graph looks kind of funny for whatever reason, you can go up to select data and then you can choose the correct data. Okay, so choosing the right things for the X and Y values, and you just click on that little button to the right of that to select that data. But mine happens to be okay, so that's cool. So here we go, we click on the data and we select that correct data. So mine's all good. We obviously need some labeling to give it some context. So we go up to add chart element and access titles, and then we can type in what we need. So our bottom one here is length of string, and we're going to obviously put our units in, which is meters. Okay. So they're just like text boxes. Again, add chart element, access title, and this time it's our vertical one. And because time for one oscillation is on our y-axis, that's what we're going to put as our label. And that will be in seconds. Okay. So we've got some axis labels. Alright, we also need to check that the axes themselves are at 0, 0. Okay, Excel will automatically format it so that your data fits the best into your graph. But if you need to change that, it should be 0, 0. You can just click on your axes and click on the little bar thing and then check that your minimums are at 0, 0 for both your vertical and horizontal axis. Okay, now like I said, these are text boxes, so we're just going to click on raw data, and then we're going to put in our informative title, our informative but not snappy title of relationship between length of string and the time taken for one oscillation. Very exciting. Okay, so that's pretty much our first graph done. Okay, we should be able to identify a curve from that. Hopefully your data is better than this. So in theory, we should be getting a square root graph, and you'll get that theoretical equation on your little information sheet when you get to the internal. So now what we need to do is start transforming that data. Okay, and I've identified that this is a square root graph. If you kind of squinted it is. So we're going to square root our length. Okay, we're going to square root what is on our x-axis. Okay, and because we're square rooting our numbers, we need to square root the unit as well. Okay, so you go to insert and then click on symbol, and you can find the little square root sign. So we're just going to type in equals and then sqrt for square root, and then click on the value we want to square root. Okay. And again, we can click on that little square down the bottom, click and drag, and it will do it for all of our lengths of string. Okay, And we want to get it so that it's at the same degree of accuracy as we measured our lengths of string the first time. Okay, now we're going to start looking at our uncertainties because we need to add some error bars. So you'll get given this percentage uncertainty for your independent variable. It'll be on your information sheet. You're just going to type it in. In this case, we're telling you it's 5%. Okay, and because we've square rooted our lengths, we need to square root the uncertainty. So again, equals SQRT for square root, and then click on 5. Okay, and again, you can click and drag, and it's going to be the same number for all of them. Now, all of our uncertainties have got to be to one significant figure. I've just put it to one decimal place here so we can still kind of see what's going on. Now, if we put this into the graph, it's going to be massive and it's not going to be accurate. So we need to turn that percentage into an absolute uncertainty. So what you do is you type in equals and you click on that percentage. You're then going to divide by 100 and then you're going to times it by the actual length that it reflects. Okay, so then we drag it down and you notice our numbers are now different. Okay, so here we're going to turn it into one significant figure. Okay, so that first number, 0.012, etc. Okay, so we've got errors for our independent, we now need errors for our dependent, and this is where our standard deviation comes in. So what we're going to do is we're going to type a little title, make it really clear for ourselves, then equals, and you just need stdev, nothing with extras, and then you're going to select all of your raw data, so each of your trials. Okay, and again, click and drag, make it to work out your standard deviation for all of them. And again, you're going to put it into one significant figure. So you need to keep going. You might have different numbers of decimal places. So this last one, I've only got 2 and everyone else I've got 3. Okay, so now I'm kind of prepped and ready for a second graph. Okay, and this is our more important graph because this is where we're going to get our straight line from. Okay, so we're going to select our square root lengths now. That's going to go on our x-axis and the average times, and we're going to again insert that same type of graph. Now here you'll notice this is not what we're expecting. Okay, so we just need to go to select data, get rid of one of those 2 entries. Okay, because we only need one series of dots on our graph at this point. So give it a name because you are going to add other things to this later. Okay, so I'm just calling this sort of data, just make it sort of clear. Then we need to select some x values, which is going to be our square root lengths. Okay, so just select those and then do the same for our y values, which is our times, which are the same as we used before in that previous graph. All right, so that's all good. We can click OK. Now our graph is fixed. Okay, so we're going to do the same as last time. We're going to label up all of the graph, make sure our axes are labelled, make sure we've got the right label for the right data, make sure that this time we are putting in square root of units and square root of length for your independent variable. So making sure we've got those titles and everything else in there that we need. Now we're going to add a trend line. This is where we add some extras to this graph. Okay, so we're going to add a trend line, okay, which is our line of best fit. Okay, because what we're going to need is we're going to need an equation. Okay, so before we get our equation, we're going to put some error bars in. Okay, so in this case I've got vertical error bars first. It's just whatever pops up. Okay, so we're going to use the error that relates to what is on our vertical axis. So you go down to custom and click specify values. Now your positive and your negative just tell you up and down from your data point. Okay, so on our y-axis we have time, so we're going to use our standard deviations. So you just click that button and select those same bits of data twice, one for positive and one for negative. And then we repeat a similar process. So now we're in the horizontal, again, custom specify value. This time we're going to look at those absolute uncertainties because those relate to what's happening in our horizontal axis, which is our square root lengths. Okay, so same thing, we're going to select the data twice, one for positive and one for negative. Click OK. And we should get a graph something like this. Okay, so I'll just click off so you can see what's going on with our errors. Okay, and we want those errors to be as small as possible because that means you've been as accurate as possible. Okay, so if we click on the trend line, all right, right click on your graph if you've exited out of that window, format chart area, make sure you click on the trend line, Okay, and then you go to the sort of bar chart bit. All right, and right down the bottom it says display equation. Okay, so it calculates the gradient and the y-intercept all for you, which is lovely. I'm just going to shift it so we can all read it. Okay, and we're going to need this later, so I'm going to copy it out of the graph and put it in a little cell by itself. Okay, so we've got our experimental equation for our experiment. Okay, but we haven't included any uncertainties in it yet. Okay, so I'm just going to copy and paste it, and then I'm going to put it into context, and this is really, really important. So y equals a number times x doesn't really mean anything to us. We need to put it in the context of our experiment. So in this case, it's going to be capital T for period equals whatever our gradient is, times by the square root of length, because that is what is on our x-axis, and then put your y-intercept in. Okay, so this is kind of where you got up to last year minus the error bars. This is the extra step. So we need to set up a little grid for maximum and minimum gradient, which is what we're going to calculate. So for your maximum gradient, starting off with your lowest data value, okay, for your x-axis first, which is your square root lengths, and then you're going to add the uncertainty that relates to that specific piece of data. And then we're going to go to our highest value. So we've shifted our data point slightly over, and now we're going to go to our highest value, and we're going to kind of shift it in. So we're going to click on that highest x value, and this time we're going to minus the uncertainty. So this time we're going to shift our highest data point slightly inwards a bit. Then we go to our y values, which is our times. So we're going to use our lowest y value, and this time we're going to minus, okay, because we're going to try and shift it down a little bit. We're going to minus that uncertainty that it relates to. Okay, and then again we go to our highest value this time, and we're going to add the uncertainty. Okay, so we're going to shift that bit up. Okay, so what we should get, all right, is our data point shifted kind of in towards each other a little bit. So we should have plus, minus, minus, plus. Okay, and then we need to basically repeat the process for our minimum gradient, but this time the signs are going to be opposite. Okay, so this time for our lowest x value, we are going to minus the uncertainty off it. Okay, it's the same uncertainty as before, this time we're minusing. And then for our highest, we're going to click on it, and this time we are going to add our uncertainty. Okay, so same values, you're just using the opposite signs. What was a plus in the maximum gradient is now a minus in the minimum gradient. Okay, on to our last value. All right, so this one should be minus, minus, plus, plus. Okay, now we need to get these onto our graph so we can draw our error lines. So now we're going to add some data. It looks slightly different on a Windows. So I'm going to call this max so I know which one I'm talking about. And my x values, I just select those two x values as I've labeled. Y, same deal. Okay, and then I'm going to add another one. Call it minimum this time. All right, and again, add my x and y values for the minimum gradient. Okay, so we should see 4 new dots come up on our graph. Okay, in this case, 2 are orange and 2 are grey. Okay, so our orange is our maximum gradient and our grey is our minimum gradient. So what we need to do now is we need to add a trend line. So if we click on the data we want to add a trend line for, add our linear trend line, that'll pop up. Click on our other piece of data because we need it for both, and add those trend lines. Okay, so they should all be there. All right. Then we're going to format that trend line. I'm just going to change it so that it's a solid line rather than sort of dotted, so it's a bit easier to see. You can have a play around at this at home. Just make it a bit thinner so we can still see our data and what's going on. And I'll do that for the other one as well. Just change the thickness and change that to a solid line so that we can see what we're doing. Okay. Then we're going to display the equation. Now remember that this is a text box, so just make sure either you can color code it or write in that it's the maximum or minimum ones. Just make sure that it's really clear to you and so therefore clear to your marker. So now I need to go up to the little bar thing, go and display my equation, and there's the equation for my minimum chart or my minimum gradient. Right, so now we've got some equations. What do we do with them? Well, we're using those maximum and minimum gradients, or maximum and minimum lines, to work out the error. Okay? So what we're going to do is we're going to just copy and paste those maximum and minimum gradients out of the graph. They'll still be in the graph, but they're more helpful if we can really see them clearly. So I'm just going to add them to the rest of the sheet. Okay. And then what we're going to do is we're going to set up another little bit. Okay, so we're going to have our gradient error. And this is just going to be our maximum gradient, the largest gradient number, minus the minimum gradient number, and then we just divide it by 2. Okay. So I've put the kind of formula there for you. You can then just type in the values. So maximum gradient minus your minimum gradient divided by 2. If you're going to do it all in one cell, you will need to put brackets around the maximum minus minimum before you divide by 2. Just so that it'll do the maths for you nicely. So there's our error for our gradient, and that as well, because it's another error, another uncertainty, that also has to be to one significant figure when we get there. Now we're just going to do the same thing for the y-intercept. So maximum y-intercept minus the minimum y-intercept divided by 2. Same thing. Okay, so there's your wee formula. Again, don't forget the brackets. So I need to do the highest value minus the lowest value. Okay, so that's what we mean by maximum minus minimum. Okay, so then we get this number. Now, our final goal is to get a final equation, all right, an in-context equation with our experimental gradient and y-intercept and the uncertainties that we have calculated, okay, because the end goal for all of this is to use our final experimental equation and compare it to the theoretical one that you get given. Okay, so I'm just putting my uncertainties into one significant figure and then putting them into the equation that I had before. Okay. So when we do uncertainties, we use this plus minus symbol. Okay, and that's how we talk about our uncertainties. Okay, and here we have it, our final equation that we're going to compare to the theoretical.